What is the value of the red angle? Hence, find tan theta. Pythagoras' theorem, trigonometric identities, quadrilateral and equilateral triangle properties are used to solve this question. Solution to question 1. Let the base angle of the quadrilateral be equals to theta. Total interior angles in a quadrilateral equals 360 degrees. This implies that the sum of 50 degrees, 80 degrees, 120 degrees, and theta equals 360 degrees. Solving for theta. It follows that theta equals 360 degrees minus, in bracket, the sum of 50 degrees, 80 degrees, and 120 degrees, which equals to 110 degrees. Let the base angle of the isosceles triangle be alpha. We have that the sum of alpha and theta equals 180 degrees. Substitute value of theta equals 110 degrees. This implies that alpha equals 180 degrees minus 110 degrees, which equals to 70 degrees. This is because the sum of angles in a straight line equals 180 degrees. Let the required red angle be beta. Since it is an isosceles triangle, it implies that the sum of 70 degrees and 70 degrees plus beta equals 180 degrees. It is because base angles of an isosceles triangle are equal. Also, the sum of angles in a triangle equals 180 degrees. Solving for beta. We have that beta equals 180 degrees minus, in bracket, 70 degrees plus 70 degrees, which equals to 40 degrees. Therefore, the red angle is 40 degrees. Solution to question 2. Label points C, B, D, E, and G. Since CDE is an isosceles right triangle, it implies that angle ECD equals angle CDE, which equals to 45 degrees. Line C equals line DE. This is given. Hence, angle ECG equals 45 degrees minus theta. By Pythagoras' theorem, the square of line CD equals the sum of the square of line DE and the square of line CE, which equals to 2 times the square of line DE. Substitute values. This implies that the square of the sum of 8 and 6 equals the square of 14, which equals to 2 times the square of line DE. Simplify and take the square root of the equation. Hence, line DE equals the square root of half of the square 14, which equals to 7 times the square root of 2. From right triangle ECG. Using trigonometric identity, line CG divided by line C equals cosine 45 degrees minus theta. This implies that line CG equals line CE times cosine 45 degrees minus theta. We call it equation 1. Consider right triangle CBG. Line CG divided by line CB equals cosine theta. This implies that line CG equals line CB times cosine theta. We call it equation 2. Since the equations are equal, equate them. It follows that C E times cosine 45 degrees minus theta equals C B times cosine theta. We call it equation 3. Substitute values. We have that 7 times the square root of 2 multiplied by cosine 45 degrees minus theta equals 8 times cosine theta. By trigonometric identity, cosine 45 degrees minus theta equals the sum of cosine 45 degrees times cosine theta and sine 45 degrees times sine theta, which equals half the sum of cosine theta and sine theta. Substitute into equation 3. This implies that 7 times the square root of 2 times the sum of cosine theta and sine theta, all divided by the square root of 2 equals 8 times cosine theta. Simplify, we have that 7 times the sum of cosine theta and sine theta equals 8 times cosine theta. Combine like terms. It signify that 7 times sine theta equals 8 times cosine theta minus 7 times cosine theta, which equals to cosine theta. Divide the equation by 7 cosine theta. This implies that 7 times sine theta divided by 7 times cosine theta equals cosine theta divided by 7 times cosine theta. Hence, sine theta divided by cosine theta equals 1 divided by 7. By trigonometric identity, sine theta divided by cosine theta equals tan theta. This implies that sine theta divided by cosine theta equals tan theta, which equals 1 divided by 7. Therefore, tan theta equals 1 divided by 7.